All right, so question 8. Once again, when you're doing these online, please make, or when you're doing these for practice, please make sure that you're able to do them not just when you're watching the videos, but that you're able to do them in isolation and are fully ready for the test. So that being said, here we go. Number 8. Use the rational root theorem to solve each equation, giving all real and imaginary roots. And I remember rational root theorem gives you possible rational roots. It doesn't tell you exactly which ones you'll have, but it just gives you possibilities. And so we take our constant value at the end and we think of all the factors for it. So 6, we've got 1 and -1. We've got 2 and -2, and 3 and -3, and 6 and -6. Now we're going to divide that by all the factors of our highest degree, the coefficient of our highest degree term. And so it's just 1. So here we've got plus and minus 1. Now we're going to take that and divide each of those. So our possible rational roots are going to be, well, what's 1 divided by 1? That's 1. And 1 divided by -1, well, that's -1. And you can keep on going through here, and hopefully we see that it's going to be -2, 2, 3, -3, and 6 and -6. Now those are your possible rational roots, and not all of them will be. And so when you're using these, it really is kind of just working through guessing and checking. Um, Use the ones that are easier for us. So as we go through, I'm going to use synthetic division. So 1x cubed minus 2x squared minus 5x plus 6, and I'll just try 1 right now. And I'm yeah, so that would be my root, and bring on the 1. 1 times 1 is 1, adds up to -1. -1 plus -5 is 6, and -6. All right, now I really did just start with the first one, and wanted to kind of play it straight. I didn't check the answer here beforehand, but that is one of our roots, is 1. So I know now that I'm going to go back through and erase some of this work here. So pause it if you want to write that down. But I found out that 1 was one of my roots, meaning that, oops, actually, let me undo that. I need to keep that information there at the end. I want to know that x squared minus x, and I'm just pulling these from down here, minus 6 equals 0. And now what are my other roots here? Or what are my other roots so I can continue solving it? So one solution here was that x equals 1. Next, this is now it's a quadratic, and I think I can factor this actually. So let's just take a look. I don't need to keep on using the rational root theorem to try to find more rational roots. Well, I'm going to have x minus 3 and x plus 2. So what are my solutions? Well, 3 and -2. All right, so 1, 3, and -2. And we got that all by starting with the rational root theorem. All right, so the second one here, we've got my possible rational roots. We've got 6, which is going to be positive and -1, positive and -2, positive and -3, and positive and -6. Divided by positive and -1 and positive and -2. So again, the numerator came from this right here, came from our constant at the end, while our denominator came from the coefficient of our leading term. So my possible rational roots are going to be positive and -1, positive and -2, positive -3, positive and -6, as well as, I'm going to kind of curl it down below here, but these are more rational roots, positive and -1/2. This would give us 1 again, so we don't need to write those down again. Positive and -3/2, and then those would give us 3 again. So we actually don't need to write those. I guess we could have fit them all in one line. Positive -1/2 and positive and -3/2. All right, and I'm once again just going to start with 1, just because it's tends to be the easiest number to divide out. So 2x to the 4th plus 3x cubed minus 12 minus 7 plus 6, and I'm going to divide it by a root of 1. we have 2, adds up to 5, -6, -13, and -13. Now those add up, and this time we don't get a remainder of 0, so that's not one of our roots. This time I'll try, guess we don't need to erase all of it. This time we'll try -1. See if we get any better results. So -1. All right. 2, -2, 1. Sorry, I lost my place. -1, -13. That's 13. Gives us 6, -6, and all right, we found it. One of my roots is -1. So I'm going to kind of erase my work here again. I know that I've got reduced this. I divided out that root of x equals -1, and I now have 2x to the third plus x squared minus 13x plus 6, all equal to 0. And now I got to keep on going. I could find some more rational roots, but if it was more possible rational roots, but it really should be the same set of numbers we had from the beginning. And so let's try it again. 2x, sorry, just 2. And then 1, so 2, 1, -13, and 6. Well, we can try -1 again. Let's see if it's a double root. So 2, -2 adds up to -1. Let's see, that's 1 adds up to -12, 12, and that gives us 18. So, all right, -1's not a double root. So we come back again. 1 I already tried earlier, so that one's out. Let's try 2 now. 2, 4, 5, 10, -3, and -6, and all right, we found one. 2 is another root of ours. So let's again, we can kind of get rid of this part because now we've divided that out. We have 2x squared plus 5x minus 3 equals 0. And I don't really need this anymore. And I could keep on continuing to go through this this method and finding more rational roots. But now I'm down to my quadratic. I've got other better ways to do it. So I'll try factoring. And I could check whether or not this is factorable first, but got a good feeling that it is. And so let's see. I've got 2 times -3 is -6x squared, and +5. So I'm looking for two numbers that multiply to give me -6, but add to give me 5. And so I've got -6x and +x. X and -6x. Factor out that negative. Did I do that right? Nope, sorry, I switched up. That should be a +x and a +6x and a -x. So negative, positive, -x. All right, that should work a little bit better. So -1 times what gives me -3? Well, that's 3. 3 times what gives me 6x? Well, that's 2x. X times 2x squared is x. And so, hoping I didn't make any other errors, we've got our last factors of x plus 3 and 2x minus 1. Now, x plus 3 gives me a root of -3. There's another one of my solutions. And 2x minus 1, set that equal to 0. Add 1 to each side, and I get x equals 1/2. So there's my fourth solution. All right, so again, use your rational root theorem just as a way to start kind of peeling away the layers until it gets to something that's a little bit more manageable. You've got some great tools for quadratics, so don't feel like you need to use the rational root theorem for every single root. We're just using it as kind of some place to start in our big guess and check problem. All right, hope that helped.